Hi, ma'am. Good evening.
Good evening, good evening. Yeah,
I have make you the co-host, ma'am. You can share the screen.
yeah, sure. I shall start.
Yes, ma'am.
Hello, everyone. Welcome to Oracle Exam Mastery Live Classes. This is Dr. Divya, Live Class Educator for Oracle. So, this Exam Mastery Live Classes we have started since June, and it is for a duration of about 45 days. So, here we are doing the rapid revision of all the important questions, quick revision of all the volatile facts. We're also dealing with all the high yielding topics as well as most expected questions in the university exams. So this is beneficial for all the university exams of all the states, as well as for those who are appearing for the NEET and PG and FMG exams. So today's class is basically on the development of genitourinary system. So before we go in for the class, let's understand the core features of Oracle for those who are new to this on this platform. So here we offer you live classes as well as recorded classes, which you can access anytime, anywhere. And we also give you a comprehensive book of these notes.
Hello, ma'am. Hello, ma'am. Hello, ma'am.
Hello.
Hello, ma'am.
Hello. There was some confusion. I think from the team, somebody called me. Okay. So they wanted
Okay.
to reschedule the class, but I said we will do half of the class. We'll start again. Okay.
Yeah, sure, ma'am.
I will
Okay.
just, yeah, yeah. I mean, I will just adjust those slides and I will leave.
Yeah, okay, ma'am.
Shall we start again?
Yeah, okay, sure, ma'am.
Yeah, sorry for the inconvenience. We'll start again. So, welcome to Oracle Exam Mastery classes. So, as I said, we are doing the rapid revision of all the important questions, quick revision of volatile facts, and we're also covering the high yielding topics of all subjects and as well as the most important or expected questions. So, today's class, we'll be basically doing the urinary system and the genital system. We'll be doing the next class. So, the core features of Oracle include the live classes, the recorded classes, which you can access anytime, anywhere. And we also have this notes which are CBFB based question and answers and MCQs. So these MCQs range from the beginner level to the expert level. So, and we have extended this limited period offer for one more day. So in case you have not yet taken the offer, that is the combo plan, which we are giving you at a special rate of 13,499 only, which includes all the app features as well as the hard copy books. You can go in for that. And we have 3 subscription plans, the basic, standard, and the mentorship. Mentorship is a wholesome program for 12 months, which we are giving you at a special rate of 50,000. And here, including the services which are given in basic and standard, we also give you one-to-one personalized guidance as well as notes. You can use the code Dr. Divya 20 for the discount on subscription. So let's get into today's class. So basically, we will be doing part of that is the urinary system today. So here we will be today considering only the development of kidney and development of the urinary bladder. So before we go into the class, let's understand a few things. Go back to the basics and come there. So now this is the embryonic disc. So this is the procaudal plate. So we have the ectoderm above, and what we are seeing is the mesoderm below, which is differentiated. Now this is the dotted line is the notochord, and we have the neural tube above it. So on either side of it, the intraembryonic mesoderm is differentiated into paraxial. This is the intermediate mesoderm, and this is the lateral plate mesoderm. Okay. So our genitourinary tract, it develops from this intermediate mesoderm. Okay. So this intermediate mesoderm forms that is the entire genitourinary system. So when we see now with the further development, so this is the neural tube, this is the notochord, this is the paraxial, and this is the intermediate mesoderm. Now this intermediate mesoderm will form what we call it as the urogenital ridge. Okay. So this will be located in the posterior abdominal posterior wall. This is the dorsal part, right? This will be the peritoneal cavity. This is the gut here. So behind the coelomic cavity, in the posterior wall of the coelomic cavity, we will have this urogenital ridge. Now this urogenital ridge will differentiate into 2 parts. The medial part will form the genital ridge, whereas the lateral part will form the nephrogenic cord. So the genital ridge forms the gonads mainly, and the duct system of the gonads are formed from there. Okay, so basically the gonads are derived from the genital ridge. Whereas the nephrogenic cord, here we have the urinary system developing from the nephrogenic cord. Okay. So this is the nephrogenic cord now. Okay, so in the development, that is basically in the development of the urinary system, it is like, we say ontogeny repeats phylogeny. Okay, so here we say, why do we say like ontogeny repeats phylogeny is basically we see all the embryological or the evolutionary. In the embryological development, we see the evolutionary stages of developing kidney. Okay, so that is why we call the development of kidney as the ontogeny repeats phylogeny. Okay, so it's a classical example for that. So what are the evolutionary stages of the kidney? Okay, so if you see, this is the nephrogenic cord. This entire orange thing is the nephrogenic cord here. So it extends from the cervical region down up to the sacral region. So we have 3 stages here. We have the pronephros, then we have the mesonephros, and we have the metanephros. The pronephros is the one which we see it in the fishes. Okay, so the pronephros, we see it in the fishes. Then we have the mesonephros, which we see it in the reptiles and amphibians. We see the mesonephros. Okay, so pronephros is basically, it will stay as a permanent kidney only in the fishes, but in humans it degenerates. Okay, then we have the mesonephros. So mesonephros, we see it, as I said, in the amphibians and some of the fishes, we can see the mesonephros. Then the metanephros, okay, this metanephros kidney, okay, this we see it in the developing embryo of humans by the third month, in the beginning of the third month of the, okay, and we see it in the sacral region. So this persists as a permanent kidney in humans. Okay. So usually this evolutionary stages of the kidney, it begins at the end of fourth week. Okay, that is at the end of 1 month of intrauterine life, or the fourth week. Usually intrauterine life, we say in terms of weeks, especially in development. So fourth week, we have the beginning. We have beginning of fourth week, we have the pronephros. Pronephros persists only for a shorter while, and then we have the mesonephros. So now this is the pronephros kidney. Okay, so this is the portion of the pronephric kidney. So we have an external glomerulus. So here what happens is, as such, the function of the kidney is not there. Okay, so it is basically the blood is coming and draining it, and it is getting filtered again, going, it doesn't get filtered as such. Okay, so this kind of kidney is not very suitable for humans. So this doesn't develop further. So if you see, what happens is, this pronephros part, it will be having these pronephric tubules, okay, pronephric tubules and the pronephric duct. So only a small portion of the duct will persist, and these pronephric tubules and the pronephros degenerates. Okay. So this is the first stage. So this, I said, we will see it in the beginning of the fourth week, basically in the cervical region. The next stage to develop from the nephrogenic cord is the mesonephros. So the mesonephros here what happens, there is a internal glomerulus, means it is having a glomerulus where it is getting filtered here, okay, a small portion, but yet this is not enough for the functional aspects of a human kidney. Okay, so that is why this also disappears. Now this pronephros will have the tubules, okay, the I said pronephros, it is mesonephros. So the mesonephros will have the mesonephric tubules and the mesonephric duct. Okay, it will have its own duct, which will be helping in the drainage. So now this mesonephric tubules, okay, they will persist. So usually in the testis, they will form the vasa efferentia of the testis. Okay, so these tubules, and this mesonephric duct will persist, and it will form basically most of the duct system of the male genitalia. If it develops further, if the developing embryo is a male, it persists and forms the duct system for the males. Okay, so this is the mesonephros. And this mesonephric duct, if you see, okay, it will be down here. It will be opening into the cloaca. Cloaca is the portion of the hindgut below the allantois. Okay, so here, see, this is the hindgut part. This is the cloaca part. So the mesonephros will be opening, mesonephric duct will be opening here. The next stage is the metanephric. So metanephros, it forms at the beginning of the third month of intrauterine life. Okay, that is about 12th week in the sacral region. So this persists as the permanent kidney because its functional aspects is more functioning is more of like which is necessary for an adult kidney, okay, human kidney, so that it develops well. So here now, that is the metanephric kidney. We will see how the different parts of the kidney and how it is developed. Okay, so now here we have two parts. Okay, in the kidney, human kidney, we have two parts. What are the two parts? One is the collecting system, another one is the excretory part. Okay, so now this excretory part is mainly derived from this metanephric blastema. This metanephric blastema, they are the basically cells of the metanephros. Okay, whereas the collecting system, okay, the collecting system is derived from the ureteric bud, which is actually developed from the mesonephric duct. Okay, so from the mesonephric duct, we have what we call it as the ureteric bud forming, and the excretory part is formed from the metanephric blastema. Okay, so this is the summary of it. So we have the pronephros, mesonephros, metanephros. So pronephros, where it is located? In the cervical region. Okay, so this pronephros and all, they are segmented. Means each segment will have its own ductules and the duct. And mesonephros, we see it in the thoracolumbar region, and the metanephros, we see it in the sacral region. So pronephros and mesonephros, they are segmented, this is non-segmented. So pronephros begins at the 4th week. This begins by the end of 4th week. It remains for some time up to the beginning of the 3rd month. Okay, so the metanephros begins there. 3rd month. Functional status, this pronephros doesn't have much functional. It disappears soon. Okay, only the duct persists. This functions, mesonephros functions for a short period and then disappears. But the tubules as well as the duct remains. Okay, the duct also remains, and tubules, few of these caudal excretory tubules, they remain. And metanephros, it functions, okay, throughout the embryonic stage and then develops into the kidney, right? And duct is the ureter which forms. Okay, so now we will see how the system develops. Now here we have the mesonephric duct, which is opening into the, now this here, if you see, this is this white thing, this both the things, these are the, okay, so these both are the portions of the hindgut. This is the allantois. So the urorectal septum develops here, which divides this hindgut portion into the primitive rectum and the, this is the primitive urogenital sinus. So this portion we call was the cloaca part. Okay. So here what is happening? The mesonephric duct, it is opening into this cloaca here. So this is the portion which is forming basically the further urinary part of the urinary system. Okay. Now in relation in this sacral region, we have the metanephros. So metanephros, it forms the metanephric blastema. What is this metanephric blastema? So this metanephros part of the nephrogenic cord, okay, it forms clusters of cells, okay, clusters of cells, which we call it as the metanephric blastema. Now, from this mesonephric duct here, what happens? It gives one small bud, and that is called as the ureteric bud, okay. So the ureteric bud, it arises from this mesonephric duct and it will grow upwards cranially. Okay, and behind the peritoneal cavity. So it will be growing towards the metanephros. So this distal end of this ureteric bud, it will be capped by this metanephros. So the growing, now this is the growing end, right? So growing end of this ureteric bud, it will get dilated. Okay, it gets dilated and that portion, it forms like a funnel, it forms. Okay, so it forms the renal pelvis. From this, again, the ureteric bud. Okay, so dichotomosely, it will, what we mean by dichotomosely means it divides in twos. Okay, so here it is dividing into two, again into two, this into two. So like that, it goes on dividing. So, and forms the major as well as the minor calyces. So of minor calyces, the collecting ducts up to the collecting tubules. So up to 13 generations, it goes on dividing. Okay, and the entire collecting system of the urinary, that is the kidney, we develops from this ureteric bud. Okay, so this is the collecting part, like how it develops. Okay, so the bud, it goes upwards. Okay, so this is the common nexus. So this is how at each of those, wherever it divides, the metanephric blastema, it comes and caps over that divisions. Okay, so this is how it will divide, major, minor calyces form. Okay. So because of this kind of thing, no, the development of the kidney is mainly like lobules, and all this will join to form a single kidney. Okay, so initially the development is in the form of lobules. Okay, so this is the development of the pelvic calyceal system, basically the collecting part of the kidney. Coming to the excretory part. Okay, so excretory part now is formed from the metanephric blastema. So, so when what happens is, when the cells of these metanephric blastema, when they come in contact with the collecting, each of these collecting, this is the collecting tubules, okay? So when it comes in contact with the collecting tubules, it will condense around it, okay? It will condense around it and it forms what we call it as the metanephric cap, okay? So that is the first stage. So first stage is the formation of the metanephric cap. So what is metanephric cap? It is the condensation of the metanephric blastema around the collecting tubule. Okay, that is the first thing. Now, this metanephric cap, what happens is, it is converted into a vesicle. Okay, it is converted into a vesicle and this is called as the metanephric vesicle. Metanephric vesicle. So this is the second stage. Now, the third stage, what happens? This metanephric vesicle, it becomes like a pear-shaped. Okay, so here the proximal end towards the collecting tubule will be narrow, whereas this distal end, it will be, it will dilate, it forms pear-shaped, okay, pear-shaped vesicle. Then this third stage, what it will form is this pear-shaped vesicle will form a S-shaped tubule, which we call it as the primitive renal tubule. So this end, okay, so if we call this as the proximal end of this will be narrow here, which will be in relation to the collecting duct, whereas the distal portion of it will be dilated. Okay, so this distal dilated end of the tubule, later on, it forms a okay. So here if you see, it forms a U-shaped depression here, correct? And this forms what we call it as the, this is the glomerulus. Okay, so this is this pear-shaped thing, no, that is dilated. It forms a Bowman's capsule. So this gets invaginated by the capillaries, that is the tuft of capillaries, no, different arterioles. So this is what is it, and it forms the glomerulus. Okay, to form the renal glomerulus. So basically, they are this renal glomerulus is developed from those angiogenic cells which are present in the nephrogenic cord. Okay. So like this, the entire excretory part is formed. So excretory part includes this glomerulus. Then this portion, it forms the excretory unit. That is the proximal convoluted tubule, the distal then the loop of Henle. Okay, the loop of Henle and the distal convoluted tubule. So up to this part is formed from which one? We are from the metanephric blastema. Okay. So this distal convoluted tubule will join with the collecting tubule, which is derived from the ureteric bud. Okay, so this is derived from the ureteric bud and to form the nephron, or what we call it as the uriniferous tubule. Okay, the entire nephron is formed here. Okay, so now I told you the metanephric blastema, that is the metanephros part. Where is it present? It is present in the sacral region. So normally, where is the kidney? The kidney is in the lumbar region, isn't it? So what happens is, this kidney slowly it ascends. Okay, so it first it will be in the sacral region. Okay, later, because why does it ascend? It ascends basically because of the development of this posterior differential growth of the posterior abdominal wall, and the fetal curvature is also reduced. Okay, all those factors, it helps. Okay, so so in the sacral region, there is no enough space. So physiologically, if you go to see, the kidney ascends basically because of the lack of space there, and for better blood supply. Okay, so for better blood supply, it ascends. So now from the pelvis, first it will be in the pelvis. From there, it ascends to the iliac fossa. Then it reaches the abdominal wall, okay, posteriorly. So these are the places it will be. Okay, so during its ascent, okay, so this is the ascent, and finally it comes to lie in the L2 vertebral level, no, that level it lies. So here what happens, the blood supply also differs as it ascends, no, the blood supply also changes. So initially, when it is in the sacral region, it is by the median sacral artery. Okay, median sacral artery, which is from the abdominal aorta. Later on, when it is in the iliac fossa region, it is supplied by the lateral splanchnic branch of the aorta. Okay, and finally, when it comes, the final position opposite the second lumbar vertebrae, it is supplied by the definitive, that is the renal artery, okay, which supplies the kidney. Then the kidney initially, the hilum of the kidney before rotation, okay, it will be facing anteriorly. After rotation, it faces medially, okay, it undergoes rotation and then it faces medially. So sometimes it can undergo abnormal rotation. See, this is normal like this. But sometimes one of the kidney, instead of turning medially, the hilum may turn laterally. Here, because it may go all 360-degree rotation here. And because of that, renal artery will encircle the kidney and open up there in the hilum. Okay. So those are some of the abnormalities of rotation. So initially the kidney hilum will be facing anteriorly and then it faces medially. Okay. So what are the developmental anomalies of the kidney? So here there is agenesis. Okay. One thing is what can happen, the metanephric blastema may not form itself. Okay. The metanephros part will not form itself or the ureteric bud may not form itself. And that will result in agenesis of kidney. Okay. Of one kidney or both kidneys is usually the newborn will not survive. Okay. So renal unilateral or bilateral can happen. So bilateral is usually uncommon, but unilateral is common. And multiple kidneys. Okay. So sometimes there may be multiple kidneys or duplication. Okay. So this is because of the early division. The ureteric bud may divide early and that will result in multiple kidneys. Okay. Then there is horseshoe-shaped kidney. Okay, horseshoe kidney or horseshoe shape. So here what happens as it is ascending, when it is ascending the kidney in the lower part, because the sacrum is small there, both the kidneys are quite close. So when they are ascending, what happens? The lower pole of the kidneys come in contact and they fuse. Okay, and that results in what we call it as horseshoe-shaped kidney. And this horseshoe-shaped kidney, what happens here? It cannot ascend up because it comes to lie beyond this inferior mesenteric artery. Okay, and its ascent further is arrested by this inferior mesenteric artery. So it basically lies at the lower lumbar vertebral level, that is almost at the level of the inferior mesenteric artery. So here the kidney has not undergone rotation yet, right? So what happens is the ureter will arise from the anterior surface, okay, of the kidney and pass in front of the isthmus in a caudal direction, okay. Then we have the polycystic. This is the congenital polycystic kidney. So here what happens, there are more cystic spaces which are filled with the urine. And so basically the entire substance of the kidney, we will see a lot of cystic spaces filled with urine. Okay. So this condition, usually it is bilateral. So what is the embryological cause for this? See, when you are writing, mainly the developmental anomalies, it is not about writing the symptoms of the disease and how much of occurrence and all those things. Embryologically, you will have to write what is the cause for it, okay? The cause of it. So here what happens is, initially it was thought that basically here it is mainly because the collecting system and the excretory system failed to connect. But now it has been proven that it occurs because of the abnormal dilatation of different parts of the uriniferous tubules. So especially in the loop of Henle and all, there is abnormal dilatation and that results in this condition. This is usually a hereditary disease and it is associated with cysts elsewhere also, like in the liver, kidney, lungs, liver, pancreas, lungs also we can see the cysts. Okay. So we have both a childhood type and an adult type of it. Okay. So basically here we need to do a transplant. So next we have the lobulated kidney. So lobulated kidney, now here what happens in lobulated kidney, So I told you the initially, like, that blastema, it just gets aborted on the each of the collecting tubules. So then all of them, they fuse to form a single. So initially this lobulated, they are still fusing. It remains same way. Okay. It just remains like that. And that results in this persistence of the normal lobulated fetal kidney. Okay. So usually this metanephric kidney, the entire fetal life, it will be like this only, lobulated. Okay, so this lobulations actually disappears during the first year after birth. So if you take a newborn's kidney and see it under ultrasound, you will see it lobulated itself. Okay, only later on, by the end of their first year, it will form a single kidney. Okay. So if it fails to happen, then it results in lobulated kidney. Then we have supernumerary artery. Supernumerary artery is basically here, that is aberrant arteries. So there is, which is more common. Okay, so it is basically, it represents the two arteries. Okay, supernumerary artery, what it represents the persistent fetal renal arteries. Okay, it represents the persistent fetal renal arteries. So fetal renal arteries, what happens is, like, we have like from the pelvis to the lumbar region, they keep changing. But sometimes if they remain, that results in the supernumerary or aberrant renal artery. So sometimes you may see. So usually we have the vein artery, renal vein, renal artery, and the, what is that, pelvis, this thing, no? The pelvis, renal pelvis. That is how the arrangement of structure is. Sometimes you may see an artery in front of it also. So that is actually the supernumerary artery which is present. Okay, here you can see. Okay. Then we have disc kidney. Okay, so this is the disc kidney. So, or otherwise called as the pancake kidney. What happens here is both the kidneys, they fuse and they form a single mass that lies in the midline. Or it may be on one side. Okay, so that is disc kidney. This is floating kidney, where it is not fixed and it results in floating kidney. Then the ureter. This is basically here what happens in the ureter. We may see double renal pelvis. Okay, so the renal pelvis is double here. So upper end of the ureter presents two renal pelvises. Instead of one, it will present two, upper and lower. Okay. So basically there is because of the premature division of the ureteric bud. Then we have the second type, which is the bifid ureter. Okay, bifid ureter, the upper end of the ureter is bifid here. If you see, two are there. Okay. Then we have the double ureter. This is the double ureter. So bifid ureter and the double ureter we have. Okay. Okay. So basically these are all because of the premature division of the ureteric bud. Okay, so when we write about kidney, so what is the source of? Source is the nephrogenic cord. Okay, nephrogenic cord, which is formed from the urogenital ridge, which is actually derived from the intermediate mesoderm. So site is basically development of the metanephric kidney is in the sacrum. Time. So the evolutionary stages begin by the beginning of 4th week. Okay, so we see the pronephros. Then by the end of 4th week, we see the mesonephros, and by the beginning of 3rd month, we have the metanephric kidney. So you have to talk about that. So mainly the collecting part is formed by which one? Okay, so the collecting part is derived from the ureteric bud. Okay. Okay, so evolutionary stages, we will talk about pronephros. Then we have the mesonephros and the metanephros. Okay, so collecting part is developed from the ureteric bud. From what structure is it derived? From the mesonephric duct. Okay, mesonephric duct forms this. Then we have the excretory part. Excretory part is formed from which one? Excretory part, we have the metanephric blastema, which is derived from the metanephros. Okay. So metanephric blastema. So this undergoes, first it forms the metanephric cap, then it forms the vesicle. Okay, then it forms the S-shaped loop. Okay, and then it differentiates into the different parts of the nephron. From this, we get all the excretory part, that is the glomerulus, the Bowman's capsule, and the glomerulus part. Then the PCT, the DCT, the Henle's loop. Okay, and we have the, these are the parts which are derived. Ascent of the kidney. What do we mean by ascent of the kidney? So the kidney develops in the sacral region. So how does it ascend? So first we see it in the sacral. Okay, ascent of the sacral. From sacral it goes to lumbar. Then we see it in the before sacral it goes to the iliac fossa. Okay, so from there it reaches the lumbar. Rotation of the kidney. So rotation of the kidney, it will be initially the hilum is facing anteriorly. Hilum will be here. Then it turns medially. Okay, it becomes medial. So anomalies, you have to write about the different anomalies. The next we move on to the development of the bladder. Okay. So the development of the bladder actually develops from the endodermal cloaca. Now this is the cloacal part, which is now divided into two parts now by the septum. Okay, so by the urorectal septum, okay, during the between 4th to 7th week of development, what happens? We have the two portions. So you can see here the two portions. This will be the urorectal septum. It divides into primitive rectum and the urogenital sinus. Okay. Okay, so this anterior part, we call it as the urogenital sinus, whereas the posterior part will be the primitive rectum. Okay. Now this cloacal membrane here, okay, which will be in relation, down here, even that will be divided by this. So where the urorectal septum will meet the cloacal membrane portion, that is the perineal body. And the cloacal membrane here in relation to the urorectal sinus, primitive urogenital sinus, we call it as the urogenital membrane. And really in relation to primitive rectum, we call it as the anal membrane. Okay. So now we will see this portion. We are concerned with this one today. So here, the mesonephric ducts are opening here, okay, in the primitive urogenital sinus. Now, this primitive urogenital sinus divides into two parts, okay. So, once where this mesonephric duct opens, that portion above this opening of this mesonephric duct, we call it as the vesico-urethral canal. And below the opening of the mesonephric duct, we call it as the definitive urogenital sinus. Okay. Got it? So this is the vesico-urethral part and this is the definitive urogenital sinus. That is the below portion. Now the definitive urogenital sinus, So this definitive urogenital sinus will further divide into two parts. The cranial part, we call it as the pelvic part, and the caudal part, we call it as the phallic part. Okay. Right. And the allantois here, it is present near the cranial end of the vesico-urethral canal. Now this vesico-urethral canal, when we see the upper part of it, it is large. Okay, so this is larger, whereas its lower part, it is little narrower. Okay, it is narrow. So this dilated part of the vesico-urethral canal, this will form what? This will form the urinary bladder. Okay. So this dilated part, it will be continuous with this allantois. So this allantois, what happens is, it obliterates and it forms what we call it as urachus. It will contribute a small part to form the apex of the bladder and it remains as urachus. Okay, and this urachus will extend all the way from the apex of the bladder up to the umbilicus. So in the adult life, we call this urachus as the median umbilical ligament. Okay. Now, the lower narrow part of it, it will form the primitive urethra. Okay, this is the primitive urethra. Okay, so the parts of the mesonephric duct distal to this ureteric bud. Okay, so slowly. Now, what happens here, if you see, so distal to that ureteric bud. Okay, so this is the ureteric bud. Distal portion is this one. This will be the proximal. So, distal portion, it slowly gets absorbed. Okay, it gets absorbed into which one? Into the vesico-urethral part. Okay. So as it gets absorbed, what happens? That absorbed parts of this mesonephric ducts into the urethral, that is the vesico-urethral canal. Okay. So it's slowly up to this portion. This is the distal portion. So up to this portion, if you see, it is slowly getting absorbed. So because of that, what happens? The opening of this mesonephric duct and the ureter, okay, that is the ureteric bud, will separate. Initially, it was opening right into this one, isn't it? But slowly this got absorbed like this. It got pulled here. So this ureteric bud shifted here. Okay. So it gets separated and they have a separate openings. Okay. With further fusion, what happens? So if you see, the ureteric opening will be moving cranially and this one. And this absorbed part of this mesonephric ducts, no, they form the trigone of the bladder. Okay. So between these two ureteric buds, and this will be called as the trigone. And this trigone of the bladder is basically formed by what? The absorption of the mesonephric duct. Okay. So you should know that. So basically the entire bladder mucosa, that is, that portion is derived from the vesico-ureteric canal. And trigone of the bladder is formed from the absorption of the mesonephric ducts. Okay, so this is the different portions. So the cranial dilated part of the vesico-urethral canal will form the endodermal epithelial lining of the entire bladder except the trigone. Absorption of the mesonephric duct forms the mesodermal epithelial lining, trigone forming the trigone of the bladder. And this planktopleuric intraembryonic mesoderm, okay, which will be around that vesico-ureteric canal. No, so where was this planktopleuric intraembryonic mesoderm? So we had that lateral plate. No? So there around that portion, we had this planktopleuric mesoderm. And same way, intraembryonic mesoderm. Okay, so that is the portion which is forming the muscular and the serous coats of the urinary bladder. And allantois, it forms the urachus and the apex of the urinary bladder. So these are so this is the main thing which you need to write when you write about the development of urinary bladder. So some of the developmental abnormalities, what we see is, so the proximal portion, it may remain patent and it forms the urachal sinus. The distal portion will be obliterated. Okay, so sometimes the entire thing remains patent and it forms the urachal fistula. So it will be opening near the umbilicus. Okay, and sometimes both the proximal and the distal portion are obliterated. With the center, it remains patent, which is called as the urachal cyst. Then other one is the epispadiasis, and this one, what we see is the bladder extrophy. So what is this one? Extrophy of bladder. Okay, extrophy of bladder or ectopia vesicae. So this is basically, this is formed. So in this, what happens? The lower median wall. Okay, so lower median wall of the anterior, that is the anterior abdominal wall, as well as the anterior wall of the urinary bladder is not present. So ectopia vesicae means it is outside. It is present outside. Okay, ectopic. So so the mucosal surface of the posterior wall of the urinary bladder showing the ureteric orifices is exposed. So the urine can be seen dribbling here, okay? And here in these cases, what happens? Epispadiasis. Okay, so epispadiasis is a common. So this is basically because of the, there is lack of migration of the mesoderm into the lateral folds of the embryo. So basically here in the hypogastric region, no? There is lack of migration of the mesodermal cells. So basically what happens is during the lateral folding of the embryo, the lateral folds are formed and they grow medially, okay? And they will fuse with each other. But here what has happened is they have failed to fuse, okay? And that mesodermal cells, no, during that folding, it would have formed this anterior abdominal muscles of the anterior abdominal wall. So in this case, where is the extrophy, what happens is, it is not formed there in this region. Okay. So the surface comes in direct contact outside. Okay, so So these are the developmental anomalies which we see there. Okay. So what do we write for the urinary bladder? So urinary bladder is developed from which one? The vesico-urethral. So what are the things forming the vesico-urethral canal? Then the allantois, okay, as well as the mesonephric ducts. All of them, they form the bladder. Okay, vesico-urethric canal, what is it forming? It will form the main bladder. Urinary bladder is formed by that at the upper part. Lower part forms the primitive urethra. It will be forming. So two structures are derived from there. Okay, allantois, it will form the apex. Rest what it will form? Urachus. Urachus will form the median umbilical ligament. And mesonephric ducts, they will form the trigone of the bladder. Okay, so basically common abnormalities, we see it in relation to urachus, that is the urachal fistula, urachal cyst or urachal sinus is seen. Okay, rarely we see the extrophy vesicae or ectopic vesicae or extrophy of the bladder is seen. Okay, so with this we complete today's class. So thank you for watching Auricle. For most of contents, you can follow social media handles, that is on the YouTube, Instagram, Facebook and Telegram. And if you haven't yet downloaded the app, please do it on Google Play and App Store and start your journey with Auricle. Until then, next time.